2 points, P and Q, in the same horizontal plane as another point, S, are 1.2 kilometers apart. The foot of a building lies at a point on QS, 600 meters away from point P. Angle PQS is 25 degrees. First, we will draw in points P, Q, and S. P and Q are 1.2 kilometers apart from each other. The foot of the building lies somewhere on QS, we do not know where exactly, so for clarity, we will indicate two possible positions for the building on QS. If the height of the building is 200 meters, calculate the greatest possible angle of elevation from point Q to the top of the building. Let's look at that a little closer. All we are told is that the building lies at a particular point on QS. We therefore do not know the exact position of the building, which is why two possible locations were drawn in. Of course, the building could be at any other point on QS. To get a better idea of where the building is positioned, consider the angle of elevation from point Q to the top of the building, and relate this to the question. We are required to determine the greatest possible angle of elevation from Q to the top of the building, given the distance between P and Q, and between P and the foot of the building. From the diagram, it is clear that the closer the building is to point Q, the greater the angle of elevation from Q to the top of the building. In other words, angle theta is greater than angle alpha. Therefore, the building lies at point M. In order to calculate the size of angle theta, we will first need to calculate either the length of KQ, or the length of QM, before we can use a trig ratio in right-angled triangle, KQM. Since QM is a side common to both triangle KQM and triangle PQM, we will therefore be looking to determine the length of QM. In triangle PQM, we know the length of two sides, PQ and PM, and the size of angle PQM. Since we are looking for the length of side QM, we will therefore use the Cos rule. You can of course also use the sine rule, but in doing so, you will be applying it twice, which is just more time consuming. So, in triangle PQM, PM squared equals PQ squared plus QM squared, minus 2 times PQ times QM, cos 25. Ensure that you use the same units of length in your calculations. Using the quadratic formula to solve for x, which represents side QM, we get x equals 1.408, or x equals 0.767. Since we have already established that the building is positioned as close as possible to point Q, for the maximum angle of elevation from Q to the top of the building, it follows that the building is 0.767 kilometers from point Q. Now that we know the length of QM, we can use a trig ratio in triangle KQM to calculate the size of theta, which is the angle of elevation from Q to the top of the building. Relative to the angle theta, Km, which is the height of the building, is the opposite side. And QM is the adjacent side. So, tan theta equals 0.2 over 0.767. Therefore, theta equals 14.6 degrees.